Hey there, this is Get Ready for Calculus Skill 16. We've already looked at the remember how. We're going to look at the rest of the skill. Parent function graphs. This is x squared. It's a quadratic. So that minus 4 means we're going to shift it down 4. That 2 in front means that we're going to double all of our answers. So instead of going up 1 over 1, we're going to go up 1 and double it over 2, or over 1 up 2. We're going to input 2 over, and normally 2 squared would give us 4 up, but we're going to go 8 up from our vertex. So 2 over and 8 up. Like that, we get mirror images on the left side, and that number in front of x squared being greater than 1 really kind of narrows out our quadratic, our parabola. All right, next one's absolute value. Anytime you have a plus or minus number inside with x, whatever's happening to x, whether it be absolute value signs, squares, square roots, that shifts the graph left or right. But it goes the opposite direction from what you expect. So negative 3 is going to shift our graph right 3. And then absolute value, well, you take the same way you would with the slope of a linear equation. And so 1 over 1, we're going to go up 1 over 1. Except for since it's absolute value, whenever we go left, we don't go down 1. We continue to go up 1. So we should have a nice V-shaped graph that looks something like that. An exponential graph, y equals 2 to the x. No numbers added or subtracted, so it doesn't shift up or down. It does start at 0. 1 is kind of the base, because 2 to the 0 power is 1. Anything to the 0 power is 1. Then we're going to plug in 1. That's 2 to the first power. You plug in 2. 2 squared is 4. Plug in 3. 2 to the third is 8. Now what happens to the left, 2 to the negative 1 power is, remember you're going to change that to 1 over 2, which is a half. And then 2 to the negative 2 power, you're going to change that to 1 over 2 squared, which is 1/4. And so you're on these exponential graphs, you will come down to a horizontal asymptote, meaning a place that would get closer and closer to without crossing. And in this case, that place is y equals 0. We'll never cross this y equals 0 line. All right, next one, y minus 4. Okay, this is just a linear equation, and it's in point slope form, so my slope is 1/2. And then my point, it's supposed to be y minus y1, so that is supposed to be positive 4, but it's supposed to be x minus x1, so it's going to be negative 2 for my point. So we're going to go negative 2 and 4 for a point, and then from there we'll use our slope up 1 over 2, or you can go down 1, left 2, and we get a straight line there. Next to last one is another parabola. This is written in vertex form. Negative 1, so that's just going to be a parabola that points down, but it's not compressed or anything like that. It's just a 1. This is my h, and my k would be the 0 that's out here. So it's supposed to be x minus h, so that's going to be a negative 3, comma 0 for my vertex. So negative 3, 0 for my vertex, going down 1 over 1, then over 2, down 4, because it's squared, over another one, down 9, 3 over, so 3 squared is 9, and you get a parabola that looks something like that. And finally, a piecewise function. So whenever you graph piecewise functions, you graph each piece separately. We're going to have a yellow piece, and we're going to have an orange piece. First of all, the yellow piece is the line y equals 4. But you don't just do a whole line y equals 4. What we see is that it only goes, our domain, our left to right, is everything to the left of 2. So up here at 4, I'm going to put a hole at 2, an open circle, and we get everything to the left at 2 will be y equals 4. Now, picking up at x equals 2, so closed circle, we get this negative 3x plus 1. So I can kind of put a little helper here. Let me change colors so that maybe it's a little more obvious I'm doing something different. So a little helper there, down 3 over 1. That's still not over to the domain starting at 2. So down 3 over another 1. Now I've hit x equals 2. So from there I can go down 3 over 1 a couple of times, and our graph is going to look like that. And I'm going to get rid of these helper points because that was just to help me kind of identify where to graph this. All right, that's skill 16, parent function graphs. Let's close with an AI-generated math joke. And let's see what AI can do for us here. Let's, since we did parent functions, let's do an AI-generated math joke. About parents. How about that? That's kind of fun. See what kind of humor AI has about parents. Why do the math teacher's parents never believe him? Because they thought he was always just making some things up. Okay. So AI has a good handle on the English language and words that sound the same, even though AI can't talk. So that's kind of interesting. I'm kind of impressed with that joke. All right, that's it for Skill 16. This is Get Ready for Calculus. Go to Pythagorean.com for resources, and good luck getting ready for calculus.